Hello, legends. Want to learn how to build AI applications? You are in the right place. Welcome to this AI programming series where I will guide you step by step from absolute zero to building real AI apps. No fluffs, just results. This might be the only tutorial you will need to kickstart your journey as an AI programmer. So let's dive in. Here's what we'll be covering in this course. Hello legends, welcome to this Python series. Now we're going to start our first session with respect to Python programming. So before we proceed with this course, we actually need a text editor. So my text editor of choice is VS Code. So if you don't have VS Code already installed in your system, and just go to Google to your Chrome, type VS Code, then you got to see the first website code.visualstudio.com. So you can click here to install for your Mac, Linux or Windows. So the installation is actually very easy and simple. So why I love Visual Studio Code is it has many plugins and many functionalities that aids you when you are coding. It's very simple to use, but if you don't like Visual Studio Code, you can actually get either Sublime, Notepad++, Bracket. There are many code editors out there and IDEs. So once you're done installing your Visual Studio Code, VS Code, so when you click here, it gets it downloaded and you can just follow the prompts to install your Visual Studio Code. So, but I will actually advise you use Visual Studio Code so you get to learn alongside with me, because this Generative AI course is going to be practical throughout. I'll show you. When you open your VS Code, first you create a folder. So when you create a folder, my own folder is Generative AI. So make sure there is nothing in your folder, okay? Then you open the folder using VS Code. When you get to here, you click on terminal, type conda, create p vmv followed by Python equal to the version you want to actually create. So you press enter or you type -y to bypass some prompts. So Python environment is actually very important in the course of your projects, because we'll be coming to that later. It helps you to manage your projects without interference from other libraries, because during the course of your projects you might actually want to download libraries and other Python levels. Okay, so why do we need to create Python environment? Creating a Python environment is the best practice in Python development because it helps you isolate dependencies. Okay, helps you avoid conflicts between your different projects on your system and help you manage your project requirements. So there are many other benefits. Okay, so whenever you are creating a project, it is advised that you create a Python environment for it. And I also advise, while creating your own Python environment in the future, always include a dash before the name of the Python environment. What this does is it makes it invincible in the folder, and it also helps Git to ignore the environment libraries. Okay, so proceeding with respect to Python, I'm not going to create my own environment because I've done it. As you can see, my environment has been done. And once you create your environment, you just click on activate. Okay, once you type activate and enter, your project is being activated for you. All right. So the first step as we are starting, is over here. I already have some projects here. So, and now once you download Conda, if you don't have Conda in your system, it is advisable that you download it so that you can be able to use Conda. You actually need to download Conda to be able to use it, and it comes along with Jupyter Notebook, which is what we are mostly going to be used in our writing and our coding in Python. So on this MacBook, this Python introduction. Now, when you say what is Python, okay, see that Python is actually a popular programming language. So it is a high-level interpreted programming language. So it is very popular because of its simplicity, its readability, and versatility. Okay, so it was created in 1991 by Guido van Rossum. Okay, so some of the features, key features of Python are: it is easy to read and write. By Guido van Rossum. Okay. So key features of Python are: it's easy to read and write. It is very, very close. The Python programming language is very close to human language, so making it beginner friendly. Alright. So also another feature is that Python programming language is interpreted, not compiled. Okay. Python programming language is interpreted. It is dynamically typed. Okay. Python programming language is dynamically typed. Okay. And it is very portable. Okay. When I say portable, it means you can run it. It works on Windows, Mac OS, Linux, etc. Even it works on Internet of Things. Okay. Python has many extensions. Okay. It has many extension libraries. So Python has thousands of modules for web development, AI, data science, automation, etc. So many of them. And then this one is quite very important. It is open source. So anyone can work with Python for free. You don't have to buy it. It is for free. You can modify it. You can add to it. Okay, you can contribute to it. That's one of the sweetest things and one of the things that make Python very strong. And Python has large community support. Okay, Python has large community support due to its being an open source project. So what are the things you can do with Python? For one, Python is used for web development. Okay. Python is used in data science. Python is used in AI and machine learning. Python is used in automation slash scripting. Automation and scripting. Python is used to build desktop apps. It is used in cybersecurity. It's also used in game development. With the Jupyter notebook we have, we can actually write, as you can see here, we can write notes and we can write Python codes. Say for example, print hello world. So we can execute codes here. We can say print 11 plus 30, okay? And when you run it, you click here to run. It outputs 41, right? And this is not the only place we can actually run Python. Natively, you can run Python on the command line, run Python in a folder. So let's say this app.py, we say name equal to at all. That's okay. Print name. Now save. So say Python app.py. It runs what's inside this file. You can see it prints out at all. So we're going to start with how do we write Python. So after introducing Python, we're going to start with how do we write Python. So guys, that's the introduction to Python programming. In our next session, we will continue with Python syntax and semantics. So guys, in this particular session, we'll be discussing about Python syntax and semantics. So first of all, we'll be discussing about what is syntax in Python. Then we are going to also discuss about what is indentation in Python. We'll discuss about comments. We'll be discussing about the use of code blocks in Python. So first of all, what is syntax? So in Python programming language, syntax is crucial in learning Python or any language at all. So syntax in Python refers to the rules that defines how Python should be written and structured so that the interpreter can understand and execute it. Okay? So think of it as a grammar in a spoken language. So let's say here I say print into parentheses with a quote hello world. I run it. It executes normally the way it's supposed to execute. So what are the key things you should notice here? In this code, there is parentheses. In this same code, there is string inside quotes, which is this. And it is also important to note that Python is case sensitive. The print word must be lower case. Say for example, I say print P capital. Yeah? Then in parentheses and a quote, I say hello world. I'm going to run this. See that we've gone into an error, which is what? It says name error. Trace back in cell in 2, that is the second cell, print hello world. Name error, print is not defined. So when the print function in Python is written in small word, this shows you that Python is very, very case sensitive. Another example of case sensitivity in Python is, let's say I say name equal to atom. Now I now go ahead and say print name. I'm going to run into lots of error. Print name, syntax error, missing parentheses in the print. Did you mean print? You see, this is a badly written Python code. One, there is no parentheses, there is no quotes encasing the words. So when you want to declare a strange variable in Python, also remember that strange variables should be declared with a quote, always, at all. Now, when I say print name, there's no parentheses. Yeah, so code will not run. Let's say now print parentheses name. We're gonna try to run it. See, it works. Name at all. Print name. But if I mistakenly, instead of writing the small letter N and put the big letter N, I say print name and run it, we run into an error. It says name, which is this, is not defined. Name error. Okay? So we're also going to check, say you wanna say print hello. So you say print, maybe you miss one of the parentheses and say hello world. Syntax error, incomplete input. Because of what? You are missing a parenthesis. Okay? Can you see it here? So it is good that you learn the Python syntax very well. You don't do mistake. A single dot can keep you for days, can keep you, it's called bug, for days without knowing where the error is coming from. And it's also important to always read the errors and understand what type of error there is in Python. Okay? Now, before I go into okay, let's go into comments in Python. So what is comments in Python? Comments in Python are lines in the code that are ignored by the interpreter. They are used to explain documents or temporarily disable parts of your code. Okay? So let's say this line of code here is a comment. Declare a name at top. So I can use hash to declare a comment and say this is a variable. Print name. When I run this code, I get atom. Okay, or let's say I assign this name to John. When I run this code again, I get John. You realize that this particular line of code is not run. Why? Because it is a single line comment. Python ignores it. Okay, let's say name John, age 25, and I say print name and print age. So when I run this, there was a mistake there. Instead of equal to, I went ahead and put a column. So let's say print John. You see, it displays the name and the age. John 25. If I want to turn maybe this age to a comment, I can just use hash in front of print age, then run this program. You won't run into error because the code has been commented out and the interpreter will no longer see this as a code. It only runs this name John, it sees the age, it sees the print command to name, but it does not see the print command to age. So this is how you write a single line comment in Python. There is also multi-line comments in Python. You can also comment multiple lines of code. Say you want to also comment here with an hash. So okay, you don't want to print all of them. Using hash, you've commented all of this, including this. And now say print, I ignored the commented lines. And when we run this, you see the only code that is being executed is this code. It says I ignored the commented lines. Now there is an official way of writing a comment. So let's go ahead and create a new file. Let me just say it is comment.py. Now, so when you encase a string literals in triple quotes, whatever you write inside here, let's say add equal to let's say a is equal to 3, b equal to 5, and say print a plus a plus b. Okay, then under here I say print hello. Print hello welcome. Now when you run this code, I'm going to save that and try to run it here. Let's say Python comment.py and run. Oh, okay. I had to cd to Python basic folder. Okay, what? Okay, let me just say take this out of Python folder. Right, it's not running because the file was inside this folder, Python basic. Okay, so now it's here in our environment. So let's run it again. You see, it says hello, welcome. Python ignores everything that is inside of these two literals, these strange literals. Okay, now that brings us to the next subtopic, which is indentation in Python. Now, what's indentation in Python? So, indentation refers to spaces at the beginning of a code. Look here. See, if 5 is greater than 2, you see the indentation, the space. So whenever you give a space in front of a code, or even in English language, say for example, paragraph, you are indenting the sentence or the line of code. So indentation in Python is very, very, very important. So unlike many other languages, Python uses indentation to define blocks of code. It's not just for readability, it's a core part of the syntax. So other languages actually don't behave like Python. So where other programming languages use indentation for readability only, the indentation in Python is very, very important. So why indentation matters in Python? In languages like C, okay, or Java, so code blocks are defined by this. They are defined by this parenthesis. Let's say if 5 is greater than 3. Okay. So in other programming languages, they usually use these curly brackets to define the line of code. You can now say print hello. So, but in Python, it's different. Python only uses indentation, removing the curly brackets, and only considering this. Okay. So when you run this, I missed a column there. Okay. When you run this, see, you get hello. So this is the correct indentation. This is what we call a code block. Okay. So let's say I shift this to here and try to run the code. We are definitely going to run into errors. Okay. Definitely. So you see, indentation error, expected an indented block after if statement on line 1. So this is a very, very important aspect of Python. So example of correct indentation, this is one. When you try to run the code, syntax is correct. So, but also remember that this is a code block. So when you say like print hello world, and you say print welcome, this is going to run. Why? Because it's not a code block. This is a call of two different functions, two prints. Yeah? While if you are coding in a code block, or you're executing a code in a code block, say for example, if age let's say age is greater than if I can get this, age is greater than 18, print you are an adult, you are an adult. So this is correct. But if you were to bring this indentation back, this is quite wrong, because the if statement is a code block and you are trying to, this print is outside of the code block because it is not indented. I don't know if I'm communicating. So when we are talking of indentation, how many spaces are we expected? It doesn't matter the number of spaces. Say for example, you can use one space. When you run the code, it's going to run. You can use two spaces. When you run the code, it's still going to run. So, but the standard is 4 spaces. That's why once you type your condition and press enter, VS Code generally gives you 4 spaces of indentation immediately. So when you're also working with functions, you often need indentation. Say for example, I want to declare a function. I say you use the def word to declare a function in Python. Def greet name. I say see, so automatically VS Code gives you an indentation. The greet name print hello name. So let's say I also say print welcome. See, okay. See, the code runs. So whichever space or indentation you might actually need, use. Just make sure you are consistent. If you are using a single space or space of indentation, make sure you are consistent with it. Okay. And if you are actually using 2 space, make sure you are consistent with it. If you are using what is it called, 4 spaces, make sure you are actually going to be consistent with your spaces to avoid errors. All right. So in our next lecture, we'll be discussing about variables in Python. So see you in our variable session. Thank you. All right, guys. So welcome to the variable session of this course. So today we'll be discussing about variable in Python, and our focus will be on introduction to variable, declaring and assigning variables, naming convention in variables in Python, checking types and conversion of variable. We'll be giving examples and errors. At the end of the day, I want you to know how to create a variable, assign a variable, know what you should consider, things you should consider while declaring a variable. All right. So first of all, let's go ahead and define Python variable. So variable is general in every programming language. Is the same in Python, is the same in Java, is the same in JavaScript, is the same in C#, C++. All right. So in Python, variables are like containers used for storing data values. Okay, so variables are fundamental elements in Python programming language. In Python, a variable is created when you assign a value to them, and they do not need explicit declaration to reserve memory space. The declaration happens automatically when you assign a value to them. Alright? So creating a variable has no command in Python. Is created the moment you assign a value to them. So it's automatically created. So let's say for example, when I said name equal to, what we did here is we declared a variable name. Let's say A. You can use anything to declare a variable, just like a single letter. I can say A is 100. Note that during the declaration of integers, you don't need quotes. So I can say is student 2. So this is a Boolean variable. Okay, later in the course, probably next course, we'll be discussing about data types. So then we are going to be treating all these data types: string, integer, Boolean values. So these are all declaration of variable. I write the name of the variable and I give it a value. I write the name of the variable and I give it a value. When you run it, it's the same. So now after you declare a variable, you assign it. So assigning a variable, okay. So we say, and now say print name. Mind you, what I'm doing now is a string. Print name, can say print age. Hey, can as well say, okay, let me print this too, so you get to see the declaration in action. Okay, I used capital letter P instead of small letter p. Alright, so that goes to show you Python is case sensitive. So now when you run it, print the name and the age. Alright, so creating a variable is as simple as giving it a name and a value. So if you want to specify the type of data you declare in a variable, actually Python doesn't need you to like specify the type of data. So say for example, I can check here and say, okay, print. So that is it about declaring a variable. So let's go to the naming convention. So it is important, very, very important, to actually give a descriptive name to variables, such as when you are giving a name of an object or a thing. It's very important you declare it with a name. Variables should be descriptive. That's the naming convention. So variables should be descriptive. They must start with a letter or an underscore. For example, let's say, let me write it down. Variables should be descriptive. They must start with a letter or an underscore, like this. For example, e.g., let's say underscore user, okay, something like this. Or, and variables can contain numbers, they can contain letters, and they can also contain underscore. So these are some of the important naming conventions for variables. So let's give example of valid variable names. Let's say valid variable names. Starting with a letter, it can contain a letter. Let's say name, small or big. Starting with small or big letters. Then equal to John. Can start with an underscore. Let's say underscore username. Can say chaos username. So it's accepted. Can as well say first name photo down Daniel. Okay, so what you cannot do in naming convention is starting a variable name with a number. Say for example, to age. See, it will not be it is not acceptable. It's already showing red. Okay? It's not acceptable. Statement must be separated by new line of code. It's not acceptable. So another example is using characters like through. It's not acceptable. Okay, so it's either going to start with a letter, underscore, or first name. You can also add a number in between. Say name 5, okay, that will go, but starting with a number is not acceptable. Also using a dash, say last dash name, is not acceptable in Python. It's either underscore or you use a camel case, and this is an example of camel case. Say last name, where you write every new word with a capital letter. Okay, so you can say last name equal to Zaram. So that's it about naming convention in Python. So we're going to head to checking data type and conversion. So checking data types and conversion. Also, you should know that you can assign multiple names to variable or multiple variables at the same time. Say, for example, let me change this in a bit. You can say X, Z, okay, and you can give them values such as red, okay, Fanta, Go, alright. You can also go ahead and print them. You already know about printing variables, alright. You can also, like the same variable, give it different names, like X, say X equal to 9. You can as well still give X. So because Python is dynamically typed, you can first of all give a name to a variable and say name is equal to Python, for example, then print name. So I'm going to copy this, I'm lazy, paste it, and say okay, now I want to give name the value of John, okay, and I can paste it again and say I want to give name the value of Jenny. So when I try to run it, the whole names get to be displayed, okay. So that's Jan there. Sorry. So as the variables are dynamic, they can change. You can change the value of the variables multiple times, any number of times you want. You understand? So you can also use variables to unpack a list. Okay. So like Python allows you to unpack a list to extract values into variables. Say for example you have a list of fruits, okay? Say you have a list of fruits here, the fruits, and then which are say apple, banana, cherry, or pineapple, okay? And now you want to unpack them with variables. You can say X, Y, Z equal to fruits. Yeah, and you can now say print X. I'm going to duplicate that, sorry. Right, hey, print X, print Y, print Z. And when you run it, there's supposed to be an equal sign here. Let's run it again. You see Arthur, John, Jenny, Sherry, banana. There's no Y. You see Arthur, John, Jenny, apple, banana, Sherry. Alright, so like you already know, the Python print function is often used to output variables. So to output multiple variables, you can use a print and a comma. Say for example, you want to output 3 variables in one print. Say for example this, instead of writing print X, print Y, print Z, I can actually use a comma and say print X, Y, okay, and Z. So when I try to run this, instead of printing multiple times, you get to see that, see, apple, banana, cherry. So you can also use the plus operator, like you can also use a plus here. You can also say plus, see, so you see the difference. There is no space here, while with the comma there is space. So in the print function, when you try to combine a string and a number with the plus operator, Python will give you an error, okay. You can combine these 3 variables because they are all strings. But when you try to say, for example, we have a number here instead of a string, let's say 20, and you try to add them together, you get an error because it's impossible to add numbers and strings. Okay, here it will go because you are using a comma. But when you try to add them together, you see that you get an error, type error, trace back, print S plus Y plus Z. Okay, can only concatenate strings, not integer to string. Alright, so the best way to output multiple variables in the print function is to separate them with commas. So when you use a comma, you won't encounter the same error. Alright, so we're going to head towards checking data types and data conversion. Okay, so these are the different data types in Python. Let's say age equal to 25. This is a string. Sorry. This is a string. You can say balance equal to 34.5, and this data type is a float, decimal, small number. Name is normal. This is a strange data type. Okay. Name Arthur is a strange data type, and like you know, like I said before, Python is case sensitive. So be watchful when you're trying to strange, okay, in your editor. So we also have another data type, which is the Boolean data type. Let's say a Nigerian is actually a Nigerian. You can say true. So when you assign a variable, either a true value or a false value, you are assigning a Boolean variable. Okay. So we can go ahead and print this. We can go ahead and print this and check the type. So we can check the type of variable using the type function. So for example, if I say type of variable of age. When you run this, it tells you age is an integer, okay? When you try to run type of variable, what type of variable is balance, you run it and you get a float, okay? So when you try it on name, you get an str, which is short for string, okay? So when you try it for Nigerian, is here Nigerian, you get a bool, okay? That's boolean, short for boolean, okay? That we can convert from integer to a string, can convert from integer or from a float to a string, but we cannot convert a string to an integer. Say for example, a string that consists of only letters, we cannot convert them to a number, to an integer or a float, but it is possible to convert a number, an integer, to a string. So let's check out for the conversion type age. You see, you get class integer, so it's telling you that age is what? Age has a class of what? Is a type of integer. So if you go ahead and put a quote on this number 25 and still run it again for the second time, unterminated, syntax, literal. Here if you watch, you will see that here I have double quotes and here I have single quotes. So that's the reason for the error. Let's run it again. See, class string, it's still 25. Why? The only difference is that here age is encased in what? In quotation marks, making it a string. Okay, so we can do this, we can actually do this for a number. Okay, let's try changing a letter. Example, say for example old. Now we remove the quotation marks and try to run old, we go into an error. Old is not defined. But when we include the quotation marks, run it, so we see a class of what? String. So let's go ahead and write my name. Okay, name equal to chatbot. Okay, then we'll now say print name. Okay, can also say print name space comma space type name. Let's see what happens. Says author and the class of the name is int. So actually, in order to convert a data type is much more easy. You just have to include the type of the data you want to convert into. Say for example, I want my name to be displayed as author. All I have to do is to be displayed as a number. For example, say name author, you want to convert this string to a number, but you know that's not possible. You just say int name. Okay, so when you try to run this, you get into an error. It says value error, invalid literal for integer with base 10 author. Okay, but let's say this is a number. Okay, let's say this is not a string, is a number. Let's say 25. Now when I check the type of data, the data type of name tells you it's a string. Removing the data type, and let's say I want this string to be converted into integer. When you write the int in front and run it, tells you it's 25. Now when we say type, okay, int name, I type integer of name and you run it, it tells you this is an integer, it's no longer a string. Okay, simply by putting the data type you want in front of the variable, we turn it into that data type, except when it is a string, that is completely letters. You cannot convert them to other data types. As long as it's a number or a float, you can easily convert it to a string or integer or even a float. Okay, so you can still convert this to a float. Say for example int name, you can still say float name. Okay, let me remove the say float. Now when I try to run it, see it's now 23.0, turning it into a decimal. Okay, all right, You can also turn a float number to a type of integer. Like you can convert float to integer just the same way you can convert integer to a float. So let's say we have a height of 11.53, okay, and we want to assign it in a variable, and we say height equal 11.53. When you check the type of string, let's print height and then type of height. Now when you run this, see that height has the value of 11.53 and the class is a float. So to convert this is very simple. We can say height, can say int height, print type of height. Okay, and when we run it, get that. No. Okay. Now I get. Let's run from here. Let me see. Alright guys, so one thing about conversion is you can actually convert the values of a variable, but for it to take effect, what you have to do is you have to put it in a new variable. Okay, say for example height here. Say that if you check, alright, if you check the print the type, the data type, print type height, okay, and send, you see that the class is float. So you can actually change this to integer, or even string. So let's say, let me put it comment conversion to integer and string str. So let's say I want to convert this to integer. What I'm going to do is I say, okay, I'm going to say int height will be equal to, you assign it to height, you say int height, int in bracket height. What this does is it converts this to an integer. So here when we say print, let's say print type int height, okay, class of height is float, Then the converted height to integer will now be int height. See, it becomes an integer. And when you want to check the value of this 11.53, you say print int height, comma. Okay. When we run it, we get 11. Okay. We round up to 11. So you can still convert this to a string. Okay. Say we want to assign str height, okay, and assign it the value of what? str. This is actually called casting. We'll get to that in a bit in the next lecture. So we'll say str height and try to print type str height. Okay. Sorry, what to in case this in a parenthesis because type is a function. Okay. Get that? You see the class changes from float to a string. So that's it. So okay guys, let's talk about another concept also in variables, which is you may ask, how can one accept inputs in Python? So input is one important concept in Python, which is it is a function in Python that allows you to input values, okay, so that you can be able to either store it or output it, so that you can use it and do other things, either run a program in a function or store in a database. And input always accept strings. For example, let's say I want to input for example, input okay, let's say name, so I don't confuse you. Let's say name equal to input. Okay, so whatever value you put here will be used as a placeholder. Let's say put also name here. Okay, and what will run this? Let's put that in a quote name, or let's say enter name. When we try to run it again, you see enter name. Press enter to confirm or escape to cancel. So when I enter my name here, author, and press enter, code runs. So we are not seeing it because we are not actually printing it out. Okay, let's go ahead and print name. Alright, let's run it again. So when I write author and enter, it displays author. Okay, so whatever the user types is returned as a string. In input, when it comes to input, please listen carefully. Whatever the user types in an input is returned as a string. Let's say, okay, we create another input, and here we are accepting age. Let's say age. Okay. Now, here we expect a number, so I can say enter age. Now, when we run this, we're going to get first of all enter name. I say I'm going to enter my name, author. Enter. You're still prompted to enter age. Let's say 25. Enter. Now, I forgot to actually print out the age, so let's quickly do that. So we're going to run it again. Say author 25. And when I press enter, you get the value of the name and the age. So this number right here we entered is being interpreted as a string. Now let's say, okay, print age. Now let's check the type. I say type age. Okay, type name. So include the comma. Now let's run it again. Now I say author 25. So when I run it, see author class string, age 25 class string. So this is where casting comes into play. Whenever you are inputting a number in using input, also always remember that the input is always a string, so we use casting to convert it. So instead of printing out the age or storing it the same way in the database, what we're going to do is we use casting. So here what we're going to do in order to change this into an integer is we introduce what? Int, input int. Okay, so what we're going to do is when we want to convert the input into an integer, before the input we enclose the whole of the input in a parenthesis and say int. Then this int, so in order to convert the input, in order to convert the input from string to an integer, what we're going to do is we say age equal to int. Using casting, we say input. So we can now say enter age. Okay, and when we run this, see the name is author 25 years. So you see now the number is being converted to an integer, and always remember that we cannot convert letters to integer or float, but we can convert float to a string, to an integer. We can convert an integer to a float or to a string, vice versa. Okay, so guys, so in order to wrap up these particular sessions, let's create a simple calculator. So you can pause the video and see if you can be able to do it on your own. After that, you can play the video and follow my example. Okay, so let's say, so to create a calculator you need two numbers. Like to get an input you need two numbers or three numbers or four numbers. But let's say num1 equal to int input or let's use float. Let's say float input enter first number. Okay, I'm lazy, so I'm going to copy it and paste. Let's say num2, please enter second number. Okay, So now let's create the following functions. Let's say add will be equal to num1 plus num2, right? Difference or minus will be equal to num1 minus num2. Product, which is multiplication, will be equal to num1 times num2. So the quotient division will be equal to num1 divided by num2. There is a typo here, syntax error. So what we're going to do is we're going to print these 4 functions. Okay, so let's say print add, print difference, print product, print quotients. Okay, so what this program does is it takes 2 numbers, add them, subtract from them, multiply the 2 numbers, and then divide the 2 numbers, and then bring out the result to us. Okay, for us to understand what's going on the print, let's say add. Okay, we'll get to understand what's happening. Difference, so on this code, let's say 20 and second number 15. So see that the addition is 15 plus 20 is 35. Difference of 15 and 20 is 5. Their product is 300 and the quotient is 1.3333. Okay, so alright, the next session of this Python series, we'll be discussing about data types. Okay, we'll be going in depth on data type, and we'll be learning about them, doing a lot of stuffs on them, on data type. So stay tuned. See you in the next class. Okay, thanks. Yo, hello everyone, I welcome you to this Python tutorial. on Python data types. So today we are diving into Python data types, the foundation of everything you write in Python. Understanding data types helps you write cleaner code, catch bugs early, and build more powerful programs. So today we will be covering numeric data types, sequence, uh, sequence data types, okay, Boolean types with real examples and explanations as we go. So Boolean types, sets, dictionaries with real examples and explanations as we go. So let's get started. So what are data types in Python? So as you know, as I said in our earlier tutorials, Python is a dynamically typed language. So what this means is you don't have to declare the type of a variable. You don't have to declare the type of a variable. Python figures it out based on the value you assign to it. Okay? So here is an example. Let's say y equals 10, x equals to 3.1. 3.14. Also, let's say name equals John. Let's say is valid equals true with a capital letter, right? So ordinarily we can be able to print these variables. We did variable in our last session, so if you haven't watched it, please go ahead and watch it before watching this tutorial. So we can simply go ahead and print out these values, but I want to check what type of variables or data types are these variables here below. And like I said previously, we use the type function to check what data type a variable is. Okay, so here I'm going to print out the data types. I'm going to say print, and inside print type parenthesis x. Okay, I'm going to copy this because I'm lazy. Paste, and paste again. So print type of x, print type of y, print type of name, and print type of is valid. Alright, and run it. So you can see the class for y is float. That's for x. Okay, let me rearrange this over here. So we're gonna run it again. So you can see, even though we didn't say int x, we didn't declare the type of the data we want to assign to the variable, Python knows that x is an integer. So here you can see x equals to 10, class of integer. Python knows that y equals to 3.14 is a float. It knows that name equals to quote John in quotation marks is a string, and it knows that is valid is equal to true is a Boolean data type. Okay, so now we are going to go ahead and check the types of data types there are. So I said there are. We're going to discuss about the different types of data type. So we're going to start with numeric data types. So I'm going to delete this numeric data types. Or let's say we have a equal to 12. Now when we print, also say b equal to -7. Let's say we also have c and assign it to be equal to 100 minus 50. So what's common among these three numbers, the minus, the operation 100 minus 50 and the 12, is that they are all the same type of data types. They are integers. These are all integers that I listed there. So if you print, say, type a, okay, Control C, then Control V, Control V. and change it to A, B, and C. Okay. When we run it, you see that so have integer, class of integer, A is an integer, B is an integer, and C is an integer. So integers is defined as what? Whole numbers, whether positive or negative, minus 1 million or 2 million or 5 million, billions, they are all integers. Okay, so whether you type 12 minus 7 or even do math like 100 minus 50, the result is still an integer. These are commonly used in loops, counters, and indices. So integers are commonly used in loops, okay, which we are going to discuss, counters, and indices. We'll be discussing those in our future sessions. So after integers, we have another numeric data type, which is float. Okay. So let me include this here. Integer. So here. The second type of numeric data type is float. Okay. And what are floats? Let me give you an example of floats. So floats are numbers with decimal points. For example, let's say F1 equals 12.5. F2 equals 10/4. So when we say print type F1, I'm going to copy and paste. F2. So when we check the types, running the code, we're going to see F1 is float, F2 is float. So in Python, even dividing two integers gives you a float. That's different from other or some other programming languages. Okay. Also, in under numeric data types, we also have complex numbers. Okay, we have complex numbers. So this is deep mathematical concept. So Python supports complex numbers. Example of a complex number is z equal to 5 plus 3j. So when you print z, let's say print z, okay, it's going to print it exactly that same way. If you've had any topic on complex numbers, this is like a complete number. Okay, so let's print type z. Okay, you see that class complex number. So this is mostly used in scientific and engineering applications. Here, the J here stands for imaginary unit. and it must always be lowercase. Let's say for example, and it's only the J, because if you replace this with, let's say, C and try to run the code, you go into an error. Syntax error, invalid decimal literal. Okay, if you use any other number, R, for example, is still going to throw up an error. Okay, so it's only J that you can use in complex numbers. So that brings us to the second type of the second data type in Python data types, and that would be Boolean. Okay, the Boolean data type. So the Boolean data type in Python has only two values. The Boolean data type, which is true and false, 1 and 0. So example is, let's say is active, and we'll give it the value of true, and let's say is empty, false. Okay, when you now try printing, or print type is active, when we run this, see, it's active, class is a Boolean. Also, let's say I also want to print the type of is empty, run it again, see, the class is also a Boolean. Okay, so the Boolean, the true or false data type, is used for decision making, like in if statements and conditions. Okay, they are used in if statements and conditions, in given conditions. Okay, so they are also used in comparisons, when you try to compare two values. Say for example, I want to say print 5 equal 9, and I also want to say print 7 is greater than 4. So let's check out the type, print type. So, or let's not just check the type, just let's run it and see what we get. It's going to give us true or false. Okay, so, and what is true or false? When you see a true variable, it's showing us that it's a Boolean value. False is also a Boolean value. Okay, so Booleans are super important. They are very, very important in control flow and logic. So also try and learn them. So now we are moving forward to another type of data type, which is sequence data type. So strings are sequence of characters. So the first type of a sequence data type is string. So let's say test1 equal to Python, and let's say okay, test2 should be 1 here, test2 equals to hello world, and then let's say multi-line string. So I can say here this is a multi-line string. So you can use single quotes, double quotes, or triple quotes to write strings. Okay, now most times when you use this, you either use it in when you want to comment out a post, when you use it without assigning it a variable, it becomes a comment. But this is used when you want to write, say like a poem, and you want it to look exactly that same way. Okay, you use the triple literals. And also when you want to use, like you want to use other quotes, a quote inside another quote, is most probably more convenient to use it in a triple quote string, okay, in multi-line strings. So say for example, want to write quotes. Okay, let's say I want to write a quote, and I say I've learned Python. Now this will throw an error when you want to run it. Why? Because Python, you see, does not accept this. Okay, invalid syntax error. Okay, if you use an apostrophe inside a single quote, Python gets confused. Either switch to double quote, or use escape character. Alright, you can either escape it, say like this. This is supposed to run. So when we run this, it's supposed to run. The mistake there is the equal sign. So when you want to use an apostrophe inside inside a sentence, you either use the double quotes, or if you were to use a single quote here, you will run into an error. Undetermined strange literal at line 9, detected at line 1. Okay, so it's either you escape it like this, then run, or you use double quotes. You use double quotes, or better still, you use the triple quotes. With triple quotes, you can write multiple statements. Say, for example, poem, say as early as the morning dew, he said, my heart longs for you. So see, we've run into an error here. When you try to run this, invalid syntax. Okay, so if you want to run a code such as this, what we have to do is, in case it's in a multi-line string, okay, so you see, it gives you the freedom to write your string, your articles, your blogs the way you want. Okay, so string has some methods, okay, properties, like string indexing. String behaves like lists, so string can be indexed. So this means that we can access each character by its position starting at 0. So you can also slice a string using range like 0.5. So let's say, for example, let's say I have a message and I want to say string indexing. Now, say I have a message. Let's create a message variable. Message equal to hello world, and I want to just print only the H in hello world. I can say print message, now using the square brackets, targeting the first index number, because index starts from 0, starts from 0, 1, 2, 3, 4 to the, even this including the space, end of the word. When I print this, you see the output is only H. You can say we want to print half of the words by dividing it into 2. That is saying print message square bracket 0 colon 5. Then when you run this, see hello. So if you know that we can do, there are many other methods in strings. So I expect you to work hard, go to W3 School, check out some things there. What I'm trying to give us is some of the most important things that we'll be working with as we go on in our generative AI course. Okay, now we have another sequence data type, which is a list. So say for example, lists are ordered collections that can be changed, so you can add, remove and update them. An example of a list is, let's say we have a list of fruits. So let's say fruits equal to square brackets, let's say apple. Remember, we always need the quotes. Let's say apple. Hello legends, I welcome you today as we continue our journey in our Python series. Today we are going to have some fun exploring operators in Python. Operators are like tools in your coding toolbox, letting you add numbers, compare values, make decisions in your program. The operators let you perform operations like addition, subtraction, multiplication, division, model. Lets you make comparisons or help you make logical decisions. By the end of this session, you will know how to use them effectively in your code with practical examples. So let's dive in. Now open a new file in your Python basics and create a new file named operations.ipymb. Alright, then with your markdown, the title is operation in Pythons. And going forward in this course, we'll be discussing various topics, the first of which is introduction to operators. So what are they and why do they matter? Okay, we are going to also discuss secondly arithmetic operators. These are operators like addition, subtraction, and the rest. We'll be also discussing about comparison operators. So we'll be covering the equal, equal to, not equal to, okay, greater than, less than, and the rest of them. We'll be discussing about logical operators such as and, or, not, etc, and the rest of them. So then we'll be having some practical examples using these operators. So let's go. So first of all, introduction to operators. All right. So one may ask, what is operators? So operators, in my own view, are special symbols in Python that let you work with values or variables. Symbols like plus, okay? Symbols like plus sign, minus sign, multiplication, division. For example, you can add numbers, compare values, or combine conditions. These are essential for building projects, forming calculations, and making decisions in your code. So let's create a new code cell, and see what happens. So we'll be starting with arithmetic operators. So arithmetic operators are all about maths. So it's all about basic maths operations like addition, subtraction. So let's create two variables. Let's say a is equal to 10, b is equal to 5. So in order to add these numbers, all we have to do is create a new variable, say maybe add results, and we say add results we assign it the variables and operators, say a plus b. So then a is our first number, b is our last number. So add results, what it does is it adds the addition of a and b. And to print out this, we say print addition using a comma. Then we call this variable add results, and this is going to output the addition of a plus b. It's going to output the results. And when we add 10 plus 5, we get 15, right? My kernel is connecting. So what this does is it prints out add results, and the answer is 15. You can still go ahead using this same a and b. Let's create another code cell. Let's say sub result a minus b, print subtraction, comma, sub results. So we go ahead and print it. Running the code will give us 10 minus 5 is 5. Okay, so using the minus operator, we can perform a subtraction operation. All right, let's open another block of code cell, block. Then let's perform the multiplication operation. Say let's create a variable mul results, mul for multiplication, result equal to a times b. Can still say print multiplication reference mul results. Okay, forgot to include a comma there, so let's go ahead and run the code. So multiplication is 50, so 10 times 5 is 50. Hope you guys are following. It's very easy. So let's say division. Okay, division in Python. Let's say div results equal to a divided by b. Print division div results. Sorry. I always tend to forget this comma. Now run the code. The answer is 2.0. Alright. So we also have floor division. As you can see, when you divide in Python, when you do ordinary division, the result that is returned is float. The data type is always a float data type. So in order to turn it to integer, or to ensure that it is a whole number, we use floor division. So example of floor division is I ought to comment the alright. Example of floor division is floor div result equal to A division divide twice B. Okay. Then we say print floor division, floor div result we get 2 as in a whole number. Okay. So what's the difference between regular division using the regular division and using double division? I explained it earlier. Regular division gives you a decimal like 2.0, while floor division discards the decimal, giving you the integer part like this. Okay, so you can go ahead and take more examples with floor division. So also another operation we are going to perform in arithmetic operations is the modulus. Okay, modulus, and that is what modulus does is it returns the remainder of a division. Say for example you divide 5 by 2, you know that each person gets 2 each, then remaining 1. So what modulus does is it returns that 1 as an answer. So let's say modulus of mod results, mod results equals A. We use the percent sign for modulus B. Okay, so print modulus, print modulus mod results. So I want you to guess the answer we're going to get, and it is 0 because when 5 divides 10, each person gets 2, remaining 0. Okay, so 10 divided by 5 has no remainder. So we can say let's say give another example of modulus. Say print modulus of 21 modulus 5. Okay, now if we perform this operation, 21 divided by 5 round this, sorry, there is no comma there. invalid syntax. Perhaps you forgot a comma. Okay. So modulus of 21 divided by 5 is 1. So 5 divided 20 is 4. Remainder 1. So the answer is 1. I'm going ahead and do check other examples in modulus. So another arithmetic operation we are going to check is exponential. Okay, exponentiation. So exponentiation is just like raising a number by its power or by another power. Let's say 5 raised to power 6, 10 raised to power 10, 10 raised to power 100. Okay, we all did, these are basic arithmetics. I believe we all did those in school. So let's say ESP result still using our variables, okay, equal to a, let's say a, an exponentiation in Python is done by double multiplication. Okay, let's say a raised to power 2. So print exponentiation. Please enclose it in a quotation mark, give a space colon, a comma, then ESP results. Run it and we get 10 raised to power 10 is 100. Okay, 10 raised to power 2 is equals to 10 times 10. Okay, 10 raised to power 3 is equal to 10 times 10 times 10, which is 1000. Okay, raised to power 5. Okay, let's say raised to power b will be what? 100,000. Okay, I believe you guys are following. So these arithmetic operators are like basic maths, so but coded in Python. So they are just, Python will help you. It also acts like a calculator. It helps you perform basic arithmetic operations. Alright, let's move to the second topic, which is comparison operators. I believe so. Comparison operators. After arithmetic, we have the third, which is comparison operators. So let me copy it real quick. Comparison operators. So comparison operators simply compare two values and return either a true or a false. It's as simple as that. So they are useful for making decisions in your code. So let's say we have two variables. Say that a equals 10, and let's assign b the value 10 as well. So using the equal to comparison, now in Python, a single equal sign is known as assignment operator. It is used in assigning a value to a variable, just as we have been doing. Just like here, we assign a the value of 10, b the value of 10 as well. But when we want to perform equal to in Python, we use double equal sign. So double equal double equal sign is used as equal to in Python. Okay, so let's check it out in a code. Let's say print is a equal to b. Okay, so okay, a equal b. So let's run the code and see what the output will be. Is a equal to b? False. That's not correct. A is equal to b. A equal to b. Returned false. Why? Okay, let me see. Okay, now it's true. Okay, so this equal to sign also works with strings. Okay, let's say we have two strings, string 1 equal to male, string 2 equal to, that is assigned male as well. We can still check if they are equal. We can say print strings equal string 1 equal string 2. Running the code, we say our strings equal, it gets false. One, because they are not equal. MEAL, while this is small letter MAEL. Okay, now if we make it the same, MEAL, and check again, see, it lets you know that they are equal. Okay, so if you know that Python is also case sensitive, say I make this into a small letter m and try this, see, it says false because they are not the same. One is capital letter M while one is small letter m. Okay, so we also have the comparison operator known as not equal to. Okay, not equal to, and is denoted by this exclamation and equal sign. Okay, so it checks if two numbers are not equal. That's its job. So let's say we have two different strings again. Let's say we have str3 equal to bold, bold, and str4 equal to bold, str4 equal to bold, let's say B with a capital letter. Checking this, say print the strings not equal. So we are checking if they are not equal. So instead of checking if they are equal, we are checking if they are not equal. The comma, are the strings not equal, and putting str3 not equal sign and str4. So when we compare the both and check, you see, are the strings not equal? It tells you yes, true. Truly they are not equal. Okay. So we also have the less than, greater than, and okay, let's check less than, greater than, equal to or greater than, or less than, or equal to or less than. So let's now create two more number variables. Let's say num1 equals, let's assign it a value of 45. Num1, assign it a value of 45. Num2, assign it a value of 55. So let's say print is num1 greater than num2. Say num1 greater than num2. So when we try to run this, we are checking if num1 is greater than num2, right? Running this, we see false. 45 is not greater than 55. You can also check this again. I'm going to copy this. Now still say print is num1 less than num2. And we have is num1 less than num2. It says true. Num1 is less than num2. You can also check greater than or equal to. greater than or equal to, which is this. Okay. Alright, let's check for that, and we'll say is num1 greater than or equal to this, and when we check, we still receive a false because the first value, which is 45, is not greater than 55, and it is not equal to 55. Okay, both of the conditions are false, so we get a false result. Okay, one will also check for if it is less than or equal to, so less than or equal to, sorry, that's not what I wanted. Okay, less than or equal to, and we'll try to print out this, which is less than or equal to. We get it is true. Okay, so after that, I think that is all about comparison operators. We're going to go ahead and start the next topic, which is logical operators. Logical operators. So logical operators combine conditions to make decisions. So they work with Boolean value, true or false. Okay, and there are three logical operations. We are going to discuss the AND, the OR, and the NOT operators. Okay, so let me give example of logical operation using AND. Let's say we have a variable and we assign it a value of true and y, variable y, and we assign it a value of true as well. So you can say print s and in capital letter, please, s and y in small letter. Okay, the mouse is running around so much. Let's say s and y. It's as simple as just saying s and y. Show us if they are true. So if one is false, we'll get a false. So s and y are true, so we are checking if both of them are true. And if both of them are true, it's just like saying is Emeka and Andy male. If both of them are male, you will get true. If one of them is not male, you will get a false. If both of them are not male, you will get a false. Okay, it's just a logical reasoning. So if one is false, we'll get a false output. But it can only be true and can only be true if both of them are true. If one is false, you will always get a false result. Okay, let's go ahead and check OR. The OR operator. So we can say, using same example, using this, let's replace and with or. Say s or, then let's say one is okay. If both of them are true, when you run this, the answer will be true. If one is false, let's see what happens. The answer will still be true. If both of them are false, then the answer will be false. So even if one of the variables in an OR operation is true, you will get a true answer. So you only get false in OR operation only when both answers are false. Okay. So OR only returns false if both are false. Then we have the not. The not, N-O-T, not. The not Boolean operator. It reverses a Boolean value. So let's say x, let's say s, and assign it the value of true, and say print s print not x. Let's say not x. Okay, so the output will be what? Not x is false. So it reverses the value that you've given to a variable. So if here x were to be false and we run not x, it reverses it to true. So logical operators are key for combining conditions, like in if statements and loops. Okay, so now let's wrap up and tie all this together by building a simple calculator using arithmetic operators. Okay, so before we go ahead, see if you can be able to do it on your own before you go ahead to watch my own solution. All right, so let me say simple calculator and one that uses input. Let's say num1 equals float input, float input enter first number. So what we are doing here is we are using casting, just like I said earlier in our previous session. whenever you use an input, the value is always a string. So, and we need to impute a float or an integer in this, especially floats. So we want to perform various operations in mathematics. So this float, what it does, it takes the input and converts it to a float value. Okay, so that's what we are doing here. I can copy this because I'm lazy. Enter, I say enter second number. Okay, so now below are the arithmetic operations. So for add, what are we going to do? We say num1 plus num2. Okay, I'm going to copy this. For subtraction, sub, we assign it the minus operator. Okay, sorry. For multiplication, mul, I'm going to assign it division, assign. Floor division, so I'm going to say floor div, sorry, floor div, assign it, then modulus, also assign it, exponent, exp, assign the operators. So what I'm going to do is, this is for add. For subtraction, we produce minus. For multiplication, we introduce multiplication. For division, we introduce division. So floor division, we introduce double division. For modulus, introduce the modulus sign. And for exponents, multiply twice. Okay, so what I'm going to do is I'm going to print all this, so to display the results. Let's say display print addition. Okay, call, sorry, add. Print subtraction. So print multiplication. Now print division and there you go, div. Print floor division, sorry, floor division floor div, sorry, print modulus mod, print exponentiation ESP. Okay. So I'm going to go ahead and run the code. So let's say, okay, I forgot a comma there. Run the code. So you see it's going to pop up here. So let's say I enter the first number as 12. So 12 and press enter, and then enter the second number as 3, enter. So what is the error? Name error. Alright. The out has a capital letter, so small letter. I'm going to run it again. Press number 12, press enter. Second number 3, press enter. So we have addition of 12 and 3, 15. Subtraction is 9. Multiplication is 36. Division 4. Floor division 4. Why? Floor division is supposed to be a whole number. So probably supposed to be a whole number. So why does it have a point? Modulus 0.0, exponentiation, which is 12 raised to power 3, 1728.0. So the problem we have here is the modulus, which I'm going to run this code again. There seems to be no mistake. So let's say 12, 3. Oh, okay. That's it. So this calculator uses all the arithmetic operators we discussed: subtraction, addition, multiplication, division, floor division, modulus, and exponentiation. Okay. You can extend it with comparisons or logical operators for more functionality, like checking if input is valid. Okay. So that's it for today's tutorial on Python operators. We've covered arithmetic operators, we've covered comparison operators, we've covered logical operators, and we've given a practical example with a simple calculator to see operators in action. So practice these operators by experimenting with different values. So in our next video, we'll be discussing about control flows in Python. So we'll be discussing about conditional statements, if, elif, else statements, and loops. Okay, see you in our next video. Don't forget to like, share, and subscribe. Thank you.